NASA detected a mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all.
On November 2nd, 2025.
At first, it looked routine. Another faint dot picked up by NASA's sky scanning system, logged, tracked, and cataloged like thousands before it. But within hours, astronomers realized this wasn't routine at all. This object wasn't just passing through our solar system, it was cutting through it. They named it 3I/ATLS, only the third interstellar object ever detected, meaning it didn't originate anywhere near our sun. It came from another star system entirely. That alone would have made headlines. But what stopped scientists cold was how it was moving. The speed was the first red flag. 3I/ATLS was traveling faster than anything of its kind ever observed, even surpassing Oumuamua, the cigar-shaped visitor that shook astronomy back in 2017. Interstellar objects are already fast by definition, but this was on another level, like it had been launched instead of drifting. Still, speed alone doesn't break the universe. Trajectories do. When researchers calculated its orbit, the numbers didn't just look strange, they looked wrong. 3I/ATLS has an orbital eccentricity of 6.14. To put that in perspective, a perfect circle is 0. Earth sits at about 0.017. Even the wildest known comets don't come close. This wasn't an orbit, it was practically a straight line. It was as if something outside the solar system pointed at our sun and said, go there. Objects shaped by gravity, curve, bend, and loop. This one didn't. It sliced through the solar system with unsettling precision, ignoring the messy chaos that usually defines natural space debris. Astronomers ran the calculations again, then again. The numbers didn't change. And that's when the quiet question started. Because if gravity wasn't fully in control here, then what was? And that was only the first problem scientists ran into. As telescopes stayed locked on 3I/ATLS, the mystery deepened fast. This wasn't just an object moving strangely, it was behaving strangely. The first anomaly showed up in its light curve. Every 16.16 hours, 3I/ATLS brightened and dimmed in a precise repeating rhythm. Not random, not chaotic, a steady pulse. What astronomers started calling a heartbeat. Natural objects tumble, spin, wobble. They don't usually keep time this cleanly. Then came the color shift. As 3I/ATLS approached the sun, it began turning bluer. That shouldn't happen. Normal comets heat up, shed dust, and appear redder as sunlight scatters through expanding debris clouds. Blue light means something far more energetic or far more control was going on. Spectroscopic data only made things worse. Instead of the familiar chemical signatures of ice-rich, dirty snowballs, researchers detected signs pointing to a metal-rich interior. That directly contradicts standard comet formation models. Comets are supposed to be fragile leftovers, not dense, structured bodies with unexpected internal complexity. And then there was the acceleration. Just like Oumuamua, 3I/ATLS began changing speed without any visible cause. No nearby planets, no obvious jets of gas, no gravitational slingshot to explain it. Yet its velocity kept shifting, subtle but measurable. Some scientists proposed exotic explanations. Cryovolcanoes erupting super cold material, invisible outgassing, unfamiliar chemistry from another star system. All plausible, all unproven. But here's the problem. Every one of these explanations works only if you isolate the anomalies. When you stack them together, the pulse, the blue shift, the metal signals, and the unexplained acceleration, the odds of coincidence start shrinking fast. This wasn't one weird thing. It was a pattern. And just as astronomers were scrambling to understand it, 3I/ATLS vanished from view. Not because it left, but because the timing couldn't have been worse. Right when scientists needed answers most, 3II Atlas slipped behind the sun. In late October 2025, the object reached perihelion, its closest point to the sun, and from Earth's perspective, it became completely unobservable. The glare of the sun wiped it from view. Telescopes went blind, data streams went quiet. On paper, that sounds normal. Lots of comets pass behind the sun, but the timing was deeply unsettling. Perihelion is when an object experiences the strongest gravitational forces in the entire solar system. It's when trajectories change most dramatically. If anything unusual were going to happen, acceleration, course correction, structural change, this would be the moment, and no one could see it. From Earth, 3II Atlas vanished for weeks. No optical tracking, no direct measurement of its velocity, no way to confirm whether it behaved exactly as predicted or didn't. That blind window triggered quiet discussions in inside the astronomy community, because there's a known principle in spaceflight, one that engineers rely on, not conspiracy theorists. It's the idea that if you want to alter your path efficiently, you do it at the point of maximum gravity. Fire engines far from a star and you barely change course. Do it at perihelion and the effect multiplies. The uncomfortable question wasn't did something happen behind the sun, it was would we even know if it did? By the time 3II Atlas was expected to re-emerge into view in December, any change made during that hidden passage would already be baked into its trajectory, detectable but only in hindsight. And that's when things took a turn no one was prepared for, because while 3II Atlas was hidden, another object appeared. On November 2nd, 2025, while 3I-Atlas was still hidden behind the sun, a new alert quietly rippled through the astronomy community. An object had been detected moving through the inner solar system, and it wasn't coming from where anyone expected. The discovery came from Gennady Borisov, an amateur astronomer whose name carries unusual weight. He wasn't lucky once. He was the same observer who discovered 2I-Borisov, only the second interstellar object ever confirmed. Now, 6 years later, had done it again. The new object was designated C-2025V1, and from the very first calculations, it didn't look normal. Start with its position. C-2025V1 wasn't trailing 3I-Atlas, and it wasn't leading it either. It was moving through the space between Earth and 3I-Atlas, occupying the same observational window at the same critical moment. That alone raised eyebrows. Then came its orbit. With an eccentricity just over 1, the object wasn't bound to the sun. It was passing through, either barely captured or barely escaping. Initial models suggested it might be interstellar. Updated calculations hinted it could instead originate from the distant Oort cloud. Either way, it sat right on the boundary between native and visitor. But the real shock was its inclination. C-2025V1 was moving at an angle of over 112 degrees relative to the plane of the solar system, almost perpendicular to the path of 3I-Atlas. Two unrelated objects appearing in the same time window, moving on radically different geometric paths, sampling the solar system from completely different angles. Statistically, it wasn't impossible, but it was deeply uncomfortable. At first, scientists were relieved. Finally, a comparison point, a normal comet to study alongside the strange one, something to anchor the data. That relief didn't last long, because as observations continued, it became clear that C-2025V1 wasn't behaving like a normal comet either, and suddenly what was supposed to be a control started looking like a second anomaly, and that's when the coincidence problem became impossible to ignore. The moment scientists began comparing the two objects side by side, the situation shifted from strange to unsettling. Neither object had a proper comet tail. That alone was a problem. Comets heat up as they approach the sun, releasing gas and dust that stretch into long, visible tails. It's one of the most reliable behaviors in astronomy, yet both 3I-Atlas and C-2025V1 showed only compact, muted comas, faint halos clinging close to their cores, with none of the dramatic streaming tails observers expected. Then came the brightness patterns. Both objects displayed irregular but structured changes in luminosity, not chaotic flickering, not smooth fading, patterns that suggested internal activity, yet without the visible outgassing that should accompany it. Whatever was pushing material off their surfaces wasn't behaving like ordinary sublimating ice, and the geometry made things worse. Their orbits weren't just different, they were almost perfectly perpendicular. One sliced through the solar system on a near straight line. The other crossed at a steep angle, sampling space from a completely different direction. In statistics, that kind of alignment isn't impossible, but when it happens during the same narrow observational window, involving two objects with shared anomalies, coincidence starts feeling like an excuse. The timing stacked the deck even further. C-2025V1 was discovered while 3I-Atlas was hidden behind the sun. One object vanished from view at the exact moment the other appeared. If you were looking for overlap, this was it. If you were hoping for independence, this was the worst case scenario. Scientists tried to stay grounded. Each anomaly on its own had a possible explanation. Unusual chemistry, rare formation environments, outgassing we can't easily detect. But explanations that work in isolation don't always survive when combined, because now the question wasn't, why is this object strange? It was, why are two unrelated objects strange in the same same way at the same time. That's when the conversation shifted. Not publicly, not in press releases, but in papers, preprints, and quiet discussions. Someone finally said out loud what many were thinking. What if these two objects aren't unrelated at all? And that's where the story stopped being comfortable. This is where the discussion crossed an invisible line. Enter Avi Loeb, a name that instantly polarizes astronomers. He's not an outsider. He's a Harvard astrophysicist, former chair of the astronomy department, and a veteran of serious peer-reviewed science. But he's also the scientist who dared to suggest that Oumuamua might not have been natural, and paid for it with years of ridicule. Loeb doesn't shout aliens. He does something far more dangerous in science. He assigns probabilities. In papers and essays published in 2025, Loeb argued that based on trajectory, timing, geometry, and acceleration, there's a non-zero and uncomfortably high probability that 3I Atlas is not entirely natural. Not certainty, not proof, just enough to demand scrutiny. One concept sits at the center of his argument, the Oberth maneuver. The idea is simple. If a spacecraft fires its engines at the exact moment it's closest to a massive body like the sun, the resulting change in speed is massively amplified. It's the most efficient way to alter a trajectory. Engineers have used versions of this concept for decades. Now, recall the timing. 3I Atlas reached perihelion while hidden behind the sun, completely unobservable from Earth. If something wanted to adjust its path without being seen, that was the moment. Then Loeb layered in the geometry. The alignments between Earth, Mars, Jupiter, and 3I Atlas weren't just visually interesting, they were statistically strained. When he ran the numbers, the probability of those alignments occurring randomly dropped below 1/100th of 1%. Rare things happen, but rare things stacked together start to matter. Then came the idea that made headlines. What if these weren't just two strange objects, but two related ones? Loeb proposed multiple possibilities. One object acting as a probe, the other as a relay or carrier, or one being natural, used as camouflage by the other. A Trojan horse scenario. Nothing definitive, just structured questions based on orbital mechanics and observation windows. And then there was a timing that refused to go away. C 2025 V1 appeared precisely while 3I Atlas was unobservable. If coordination existed, that was the only window it could happen undetected. To Loeb, ignoring these questions wasn't cautious science, it was avoidance. To many others, even asking them felt reckless. The astronomical community fractured into camps, not believers versus skeptics, but those willing to tolerate uncomfortable hypotheses and those determined to shut them down early. And just as the debate reached a boiling point, December entered the conversation, because that's when speculation would finally collide with data. As fast as the speculation spread, the pushback came even faster. Within days, astronomers across the world moved to shut the door on anything resembling an artificial explanation. Not because the data wasn't strange, but because, in their view, strange does not mean engineered. The first counter-argument is simple. Comets are chaotic. We've observed thousands of them, and no two behave exactly the same. Outgassing can occur unevenly, jets can fire from hitting cracks, exotic chemistry can mimic thrust without producing visible tails. According to skeptics, 3I-ATLS and C-2025 V1 might look unprecedented only because we've never seen interstellar comets up close before. And that leads to the second objection, sample size. So far, humanity has detected just 3 interstellar objects. 3. That's nowhere near enough to define what normal even looks like. What if all interstellar visitors behave like this? What if Oumuamua wasn't the outlier, but the first warning that our assumptions were wrong? Then there's the silence. Radio observatories, including facilities tied to SETI Institute, pointed their instruments toward both objects. No transmissions, no repeating signals, no artificial modulation, nothing that resembles communication or technology. If these were probes, skeptics ask, why are they completely quiet? Composition adds another layer of resistance. Spectral data shows ice, rock, and organic compounds, all consistent with natural bodies. There's nothing obviously manufactured, no alloys, no exotic materials, no energy signatures that scream engineering. Unusual, yes. Artificial, not even close, according to the mainstream view. And then there's the Avi Loeb problem. To many scientists, Loeb burned his credibility with Oumuamua. His willingness to entertain extraterrestrial explanations made him a magnet for headlines and a liability in a field built on caution. To his critics, this is history repeating itself. Patterns overinterpreted, coincidences inflated, uncertainty mistaken for intent. From this perspective, Borisov's discovery isn't suspicious, it's expected. Skilled observers find rare things. That's what they do. Two strange objects appearing close together doesn't imply coordination. It implies we're finally good enough at looking to notice them. Still, even among skeptics, there's an uneasy admission. They agree the behavior is unprecedented. They agree existing models are incomplete. They agree something doesn't quite fit, which has led to a growing middle ground. Scientists who reject artificial explanations, but also reject the idea that this is business as usual. Something unusual is happening. The disagreement isn't over whether the data is strange anymore. It's over what kind of strange we're dealing with. And that debate won't be settled by opinion. It will be settled by what happens next. For months, the debate lived in papers, interviews, and speculation. December is where it meets reality. On December 19, 2025, 3I ATLS reaches its closest approach to Earth, about 170 million miles away. That might sound distant, but in astronomical terms, it's a gift. This is the window where precision measurements become possible, where predictions either hold or crack. Every major observatory is ready. Ground-based arrays, space-based platforms, instruments operated by NASA and international partners. The goal isn't to prove a theory, it's to stress test every explanation at once. Scientists will be watching for a short, brutal checklist of signals, trajectory drift, even tiny deviations from predicted paths, non-gravitational acceleration that can't be explained by outgassing, brightness anomalies that repeat or synchronize, fragment release or unexpected debris, any sign that activity occurred during the hidden perihelion window. At the same time, C/2025 V1 will still be observable as it exits the inner solar system. For the first time, both objects can be studied simultaneously with maximum sensitivity. Same instruments, same conditions, no excuses. This is where coincidence either collapses or hardens. And it won't just be professionals watching. Amateur astronomers around the world are preparing their own observations. With a sufficiently powerful telescope and dark skies, 3I ATLS should be visible in the constellation Leo, near the star Regulus. Citizen science has changed astronomy before. This time, thousands of independent eyes will be locked on the same patch of sky. If nothing unusual happens, skepticism wins ground. If something subtle happens, the debate intensifies. If something coordinated happens, there won't be a press release fast enough to contain. December is the checkpoint no theory can dodge. No narratives, no headlines, just data. And once that data arrives, the story doesn't end. It branches. Once December's data is in, the story doesn't resolve into a neat answer. It splits into outcomes, each one unsettling in its own way. Best case scenario, both objects settle down. No further acceleration, no strange brightness shifts, no deviations from predicted paths. The anomalies turn out to be rare but natural physics, unfamiliar chemistry, exotic ice behavior, or a class of interstellar objects we simply didn't know existed. Science adapts. Textbooks update. The mystery fades, replaced by understanding. But even that best case isn't small. It would mean our models of comets, especially interstellar ones, have been wrong for decades. That material from other star systems behaves fundamentally differently than anything born near our sun. We wouldn't be alone in the universe, but we'd still be ignorant of how much we don't know. The concerning scenario sits in the middle. December reveals more anomalies. Subtle, repeatable, but still explainable in multiple ways. Additional non-gravitational acceleration. Brightness changes that don't match outgassing models. Structural behavior that feels organized. Nothing that screams artificial, but nothing that fully fits nature either. That's the dangerous zone for science. Not confirmation, not dismissal, just tension. It's where debates stretch on for years, where every new data set reopens old arguments, where the mystery refuses to die. Oumuamua lived in that space, and it still does. Then there's a scenario no one wants to say out loud. The worst case scenario. Clear evidence of coordination, synchronized behavior, objects deploying material, trajectories adjusting in ways no natural process can mimic. Not a message, not a landing, just proof of intent. If that happens, it wouldn't look like a movie. There would be no announcement, no dramatic reveal. There would be silence first. Scientists checking their work again and again, afraid of being wrong about the most important discovery in human history. Because at that point, the question wouldn't be what are these objects? It would be who sent them and how long have they been here? And that question doesn't belong to astronomy alone anymore. It belongs to everyone. Whether 3I AT Atlas and C/2025 V1 turn out to be ancient space debris, rare cosmic wanderers, or something far more deliberate, one thing is already certain. The universe just reminded us how little control we really have over the story. Somewhere between Earth and the stars, two visitors passed through our neighborhood. And for the first time in a long time, humanity had to admit something uncomfortable. We don't know what's out there, but we're finally paying attention. No matter how this ends, something irreversible has already happened. For the first time, humanity didn't just notice an interstellar visitor. It noticed patterns, timing, geometry, behavior that forced scientists to stop saying probably nothing and start saying we need to watch this carefully. If 3I Atlas and C2025 V1 are natural, then nature is far stranger, more creative, and more unpredictable than our clean equations ever suggested. It means the universe has been sending us messengers from other star systems all along, and we were blind to them until now. And if they're not, then December 2025 won't be remembered as the moment we met anyone. It will be remembered as the moment we realized we might not be alone, and never were. Not with flashing lights, not with signals, but with quiet observation. Civilizations capable of crossing interstellar space wouldn't need to announce themselves. They wouldn't need permission. They'd study, measure, observe, just like we do when we encounter something smaller, weaker, or less advanced. That idea unsettles people, not because it's scary, but because it reframes our importance. The universe doesn't revolve around us. It never did. Right now, somewhere far beyond human reach, answers already exist. Whether we're looking at ancient debris, cosmic coincidence, or something deliberate, the truth doesn't depend on belief. It depends on evidence, and evidence is coming. By the time you're watching this, the data may already be in, or it may have raised even more questions. Either way, one thing is certain. The story of these two objects didn't begin when we noticed them, and it won't end when they leave. This wasn't a warning. This wasn't an invasion. It was a reminder. We are newcomers to a universe that's been active for billions of years, and we're only just learning how to look up.